Hello scholars, welcome back to the channel. We're going to be looking at pictographs. It's the first video in the series of videos on graphs. So we're going to be looking at line graph, bar graph, pie charts, the whole range of graphs. Alright, so what is a pictograph? A pictograph is a representation of information using pictures to represent the things that we're talking about in combination with numbers. Now, picture writing actually was the first kind of writing that humans did, right? Our first, on record, the first human writing, it was called hieroglyphs. And this was found in Egypt. Then their name for their writing was Medu Neter, or the language of the gods. So their words were in the form of pictures to represent ideas. And that is how our written language evolved to what we use today. These symbols that we have to represent words representing ideas. Alright, so the pictograph has pictures of things. It can be an actual representation, in other words, actually how the thing looks, as well as it can just be a symbol that represents the thing. So we could say we use a triangle to represent a mango, or we can draw something that looks like a mango to represent a mango. Alright, so the key, so this is our key. The key tells us what each picture, what each symbol represents. So the title of this pictograph, because all graphs must have a title, Favorite Fruits of 4A. So the students in 4A have expressed to their teacher what their favorite fruits are. And these are the favorite fruits of the children in class 4A. So for the mango, 18 students said that mango was their favorite fruit. 6 students said that orange was their favorite fruit. 7 students preferred banana. 16 students preferred grapes. And 12 students preferred watermelon. Now, as soon as we look at the pictures, we can see that's a mango, that's an orange, that's a banana, these are grapes, that's a slice of watermelon. And that is the power of the pictograph. Right? Because remember, like I said, pictures were the first way humans started expressing themselves, drawing symbols that looked as much as the thing that they were referring to. Carved into rocks, in caves, right? Carved on monuments. So we have all these things to show us how our ancestors tried to communicate with each other. As soon as you see the symbol, you know what the thing is, what we're trying to say. Alright, but like I said, we can also have symbols that don't look like the thing at all, but the key should tell us what the symbol represents. Now, we're going to fill in what is called a tally chart. And the tally chart is written with strokes. So 1 stroke for 1 item. Now, when we get to 4 strokes, the next stroke to make 5, we're going to draw it diagonally to make 5. So for mango, 18 students say they prefer mango. So remember now, we're counting in groups of 5, and when we get to 4, so 1, 2, 3, 4, we draw it diagonally for 5. So that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's how we would represent the number of mangoes, the number of students who prefer mangoes, on the tally chart, 18. So 3 groups of 5 plus 3 more. How about orange? 6 students say they prefer orange. So on the tally chart, 1, 2, 3, 4, 5, and one more, that's 6. Banana, 7 students prefer banana than the other fruits. So 1, 2, 3, 4, 5, 6, 7. 7 students prefer banana. Are you getting the drift of this? Getting the hang of it? 16 students say they really love grapes. They prefer grapes more than all the other fruits. So let's represent the students who prefer grapes. 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and one more for 16. And how about watermelon? 12 children say they prefer watermelon than all the other fruits. So how are we going to represent 12? 1, 2, 3, 4, diagonal for 5. So that's 5, 6, 7, 8, 9, 10, 11, 12. So we have taken this information, this raw information that was given to us, just stating how many children prefer each fruit, and the symbol, the actual symbol that looks like the fruit, was used to represent the fruit. And beside that, the number of children who prefer that fruit. So we transferred that information to the tally chart using tally strokes, and we count in groups of 5 on the tally chart. When we get to 4, so it's 4 vertical strokes. When we're to do 5, we make it diagonal. So it's slant for 5. So for mango, 5, 10, 15, and 3 more, that's 18. For orange, 5 and 1 more, that's 6. For banana, 5 and 2 more, that's 7. For grapes, 5, 10, 15, and 1 more, that's 16. For watermelon, 5, 10, and 2 more, that's 12. So let's answer these questions based on the pictograph or the tally chart. We can use either one to get the information. What is the total number of students in class 4A? So since they're saying that all the children answered the question, all the children chose one of the fruits, all the children participated in the survey, so we can add up all of these to get the total number of students. So that would be 18 plus 6 plus 7 plus 16 plus 12. Alright, let's add it here. So we have 18, 6, 7, 16, and 12. 2 and 6, 8, and 7, 15, and 6, 21, and 8, 29. 2 and 1, 3, 4, 5. So 59. 59 students. 59 students in all in the class. That's a big class. That's a very big class, right? How many students are in your class? How does it compare to this class? That's a big class. Alright, which fruit is loved twice as much as orange? Which fruit is loved twice as much as orange? We know that twice means 2 times. So 2 times as much. So let's find orange. They are referring to orange, so first we need to go to orange to see how many liked orange before we can decide which other fruit was liked twice as much. So 6 children said their favorite fruit is orange. Twice 6, 2 times 6 is 12. So which one of these had 12 students saying it's their favorite? Watermelon. So watermelon was loved twice as much as orange, because orange was loved by 6 students Watermelon was loved by 12 students. That's 2 times 6. Question 3. Which is the most popular fruit? So the most popular fruit would have more children saying that they like it. That's what popular means. More people like it, right? If you're a popular student, a lot of people like to be around you. When you're coming into the school, everybody's waving at you, calling to you, want you to come and talk to them if you're a popular student. So the most popular fruit would have the most children saying that they love that fruit. Which one is it? So the biggest number here is 18. But we should not write 18. Should we write 18 here? Did they ask us how many children like the most popular fruit? No. They said, which is the most popular fruit? They don't want us to tell them how many children like the most popular fruit. They want to know which fruit was the most popular. So the answer we're going to give is mango. Mango was the most popular fruit. Which is the least popular fruit? The one that the fewest number of children liked. The smallest number in the list. So that would be orange. 6 children say they prefer orange. 6 is the smallest number of the lot. So the least popular fruit then was orange. How many children prefer grapes? Now this time they want the number. These 2 is asking for the actual fruit. They're saying which fruit? Which fruit? These 3. This one wants a number, not a fruit. They want a number. How many children prefer grapes? So we go to grapes and we see that 16 children said, we love grapes more than all the other fruits. 16 children prefer grapes. So we're going to put 16. If we want, we can put children beside it. 16 children say they really, really love grapes. Number 6, how many more? How many more children prefer mango than banana? They're not asking you to write how many children love mango. They're not asking you to write how many children love bananas. Even though you need to know these 2 things in order to make the comparison. They're asking how many more of them prefer the mango than the banana. So we need to subtract to see how many more. So 18 love mango the most. 7 love banana the most. How many more is 18 than 7? We need to subtract. So we can put 18 subtract 7, and that is 11. 11 more children prefer mango than bananas. So we need to make sure that we answer the question that's being asked. Don't give irrelevant answers. Let's look at another pictograph. This time, the title of this graph is Houses at Summer Camp. So you know when you go to summer camp, for those of you who have been to summer camp, and some of you I know every year you want to go, you beg and beg and beg to go back to summer camp because you enjoy yourself there. So they divide the children up into houses, and you stay in this house, you stay in that house, you stay in that house, right? So at this summer camp, they have 3 houses. House A, House B, House C. And they're telling us they're using pictures, diagrams, symbols to represent the number of children who are staying at each house. The key or the legend is telling us what each symbol represents. Now, this is very important. This is a common mistake made. Many students just look at the diagram and they say, oh, this is a person, so that's one person. It's not always the case. Sometimes it might represent just one person, but you have to look at the key to see what the symbol represents. This key is telling us, if you see a person like this, it actually represents 10 persons. If you see a person with 2 arms, 2 legs, it represents 10 persons. If you see a person with only 1 arm and 1 leg, that represents 5 actual persons. And if you see a picture of a person with no arms, no legs, that represents 2 actual persons. That's very important. Always look at the key to see what the symbols represent, because they don't always represent one thing. Maybe one symbol represents 2 persons, one symbol might represent 100 things. It all depends on how many things or how many items or persons were in the group, and so they have to find a way of representing a huge number of persons with symbols. So it's not always one representing one. You have to be careful. So which house has the most children staying there? Let us write the number of persons staying at each house first, just so we can be able to compare properly. So we are told, remember, if it's a full person, it's 10 persons is represented. 1 arm, 1 leg, 5 persons. No arms or legs, 2 persons. So here we have 2 full persons, so that's 10 plus 10, that's 20 actual children. And then we have 5 more and 2 more, so that's 27 children. Do you see that? Some students would say, oh, that's 1, 2, 3, 4. No. You have to look what the symbols represent. This represents 10, that represents 10, that represents 5, that represents 2, and you put them together. So that's 25, 27. For house B, we have 4 full persons. So that means 4 groups of 10, which is 40 children. 40 children are in house B. For house C, we have 10 plus 5, 15, plus 2, 17, plus 2, 19. Okay, so house B looks crowded. Maybe they should take some people out of house B and put them in house C. Or maybe house B is just a bigger building, right? Maybe this is a smaller building and it can only hold a smaller number of children. Maybe house B is a huge building with lots of beds and space. Alright, so let's look at the question. Which house has the most children staying there? Now that we have added up the number of children, we can easily look and we see that definitely house B. House B has the most number of children staying there. How many more children are staying in house B than house C? Alright, so house B has 40, house C has 19. So 40 subtract 19, that gives us 21. 21 more children are in house B than house C. Number 3, which house do you think could hold more children? Well, just looking at the numbers, I'm saying house C because it has the least number. We don't know if it's a case where house C is just a tiny, tiny little building, and house B, maybe house B has the most space and can even hold more. We don't know. But just looking at the numbers, and let's assume they're the same size buildings, I would say house C could take a couple more children, right? If we're looking at it to say it's the same size. We don't really know, but that's a fair estimate, a fair comparison. Final question. Which house needs 13 more to have the same number of children as house B? So house B has 40. Which one of these need 13 more to make 40? House A. Because we already worked out that the difference between house B and C is 21, not 13. But just to check, let us take the number of children from in house A from house B and see what we get. See, we get 13. So that is house A. House A has 27. It needs 13 more to make 40, which is what house B has. Alright, so that's it for the pictograph. Just remember, a pictograph will have actual pictures. That's why it's called a pictograph. Remember, I told you in maths, you need to have your dictionary beside you because things get their names based on what they are. So if you know what the word means, you're halfway in understanding what the maths is about. The pictograph has pictures to represent quantities, represent items that we're comparing the quantities of. If you have been helped by this video, just drop a line to say, "Thank you, Miss," and share the video, please, so that other students might benefit from the information in the video. If you have not subscribed, I would encourage you to do so, as well as to click the bell so that you will be notified as soon as a new video comes out, so you can stay on top of things, stay ahead of the class. And if you're searching for a particular topic, you don't see it in the catalog, just let me know in the comments which topic you'd like me to do a video on, and I'll speed up the process for you. Thank you, my scholars, for joining me. Remember to practice your maths, practice, practice, practice. I'll see you in the next video.